Assalamualaikum warahmatullahi wabarakatuh, and greetings. My name is Muhammad Zunnurrainie bin Zulkifli, and now I'm going to present about my proposal defense. So this is my metric number, and my supervisor is Dr. Fathinul Syahir. So the title for my proposal defense is Acoustic Impulse Response and Ultrasound Wave Response for measuring the firmness and insidious fruit rot of mango. I'm from Faculty of Electrical. Without further ado, shall we continue these presentations? So the outline for my presentation today, I will cover from introductions, problem statement, objective, past research, methodology, result and discussions, and on the last will be the questionnaire sessions. Okay, so now we go to the introductions for my research. So basically, for this project, I need to do the development of acoustic impulse response and the ultrasound wave response. Okay, both of the sensing response is important in order to determine and to check the presence of insidious fruit rot. So in the short form is IFR. For your information, IFR is an internal disease or internal defect that always occur on harum manis mango. So this device is developed in order to check the presence of IFR. Now we go to the problem statement of the research. So the thing that most motivate us to develop this device is that until now there is no device that was able to accurately detect IFR disease inside of the harum manis mango. Up until now, the farmer and the cultivator only use the traditional method, that is to manually check each of the fruits. So this is very time consuming and not productive. When we traditionally check each of the harum manis mango, there will be human error, and we as the researcher would like to reduce this human error and to get a more accurate data output. A more accurate data output will help the grower and the cultivator to get to avoid selling the faulty and defect fruit to the customers. Okay, after the problem statement, now we will go to the research objectives. There are three main objectives in this research project. So the first objective is to develop acoustic impulse response system that will be able to measure the firmness and detect the IFR inside the Mangifera indica L harum manis, that is harum manis mango. So the second objective of this research is to develop ultrasound wave response that will be able to detect the presence of IFR inside the harum manis mango. And for the last objective of the research is to investigate the quality of internal properties of harum manis mango. Now we go to the research question. So the first question is, why the usage of acoustic impulse response? And the next is, why the usage of ultrasound wave response? For the third question is, how to formulate the indication of level to be able to detect the presence of IFR using acoustic impulse response and ultrasound wave response. And for the last research question is, how to design the mechanical structure to ensure the input sensing data is accurate. As for the past research, there are two major methods that constantly used. The first is impact method, and the second is sine wave method. So for this research paper, I choose to upgrade the impact method to another level to get a better accuracy, a better result, and more consistent result. As for the swipe sine wave method, I upgrade it by using a piezoelectric transducer. Okay, so the device will vibrate the fruits, and then the piezoelectric sensor, voltage sensor, we measure the vibrations and we convert it to the voltage. And by using the voltage measured, we will be able to detect the internal properties of the harum manis mango. So now let's go to the methodology, and I will explain about the hardware development for this device. So the microprocessor that I use is Raspberry Pi 4 that I equipped with the touchscreen LCD screen. So why do I use touchscreen? This is for me to create a monitoring system. Okay, so the second reason is that the touchscreen LCD can be accessed easily to configure any error during my troubleshooting sessions. And the last reason why I use this is because it is compatible and easy to command the activation for the hammering mechanism to start. Okay, next is for the hammering mechanism and the measuring for the knocking sound. Okay, so to create the knocking sound, I use linear mini solenoid actuator. Okay, this will be hammered and will be touched to the surface of the fruit, and it will create a knocking sound. The actuator force was calibrated to ensure not to deform any of the fruit's surface. Okay, when the knocking sound was produced, the mini USB microphone will measure and record all of the frequency and all of the decibel into the microprocessor to process it using the algorithm that I use. This is the adjustable step-down buck converter board. I use this to ensure there are no overflow in the power supply into the Raspberry Pi 4. This will ensure the safety of the sensor that I use, and it will not burn the sensor. Okay, the solid state relay is to ensure the mini solenoid valve does not jam when we press the start button repeatedly. And this is the main power source for this device, that is 12 volt only. And all of the hardware that I tell before is placed inside the PVC electric box. This is to avoid the component from potential hazard such as water and so on. Okay, now we go to the two additional device, that is ultrasound transducer, ultrasonic piezoelectric transducer. So this emit a high frequency that will vibrate the harum manis mango. Okay, and the bottom is piezoelectric voltage sensor. So this sensor is to measure the hertz of the vibration from the harum manis mango, and from the vibration it will convert into the value of voltage for further analysis. And this is the first prototype that I assembled. Okay, so as we can see, the black foam is where we will place the fruits, and the center of the foam that will be hole, and I place the mini actuator and the microphone sensor there. Okay, so the foam will act as a sound barrier to ensure there are no outside sound that will interfere with the data I collect. And the collected data will be shown in the LCD display. And now we will go to software development, and the programming language that I use for this device is Tony Python IDE. Okay, this is the most suitable for me. Okay, so now we go to the system development, and this is for the testing and evaluating the fruit sample. So the number of sample that I use is 100. Okay, how do I test the sample? Is that I put the fruit, the top segment of the fruit, to the microphone sensor and press the start button to start the hammering process. And I will take the top segment reading 3 times and the bottom segment reading 3 times. We will get the average, and the difference between the average will determine whether the fruit contain any IFR or do not contain any IFR disease. Okay, that is the flow of the device during the testing session. Okay, so now we go to the result and discussions, and in the slide is shown the last version of this device. So we improve the span a little bit to improve the sound cancellation and the sound barrier to ensure no outside sound can interfere with the data. Okay, now we go to the user interface that I create. Okay, this is the display that we shown in the LCD screen. Okay, in the screen there are bottom acquisition, top acquisition, and analyze data. Okay, when we place the top segment of the fruit on the white span, okay, we will press the top acquisition on the screen, and the device will give a gentle tap to the fruit, and the frequency will be recorded, the sound frequency will be recorded through the microphone sensor, and the data will be sent to the microprocessor, and we will repeat the procedure using bottom segment of the fruit, and we will press the bottom position. Okay, after finish both side of the fruit, okay, we will press the analyze data, and the algorithm will analyze, the microprocessor will analyze, and the result will show whether the fruit contain IFR disease or do not contain IFR disease. Okay, in the slide, I insert 5 of the 100 sample that I used to determine the IFR. Okay, as we can see, there are top segment and bottom segment. I take 3 times to get the top average and the bottom average. And the difference between top and bottom average will determine whether the fruit contain any IFR or do not contain any IFR. Okay, as we can see in the scatter plot beside, there are a level that distinguish between a harmonious mango that contain IFR and do not contain IFR. And I stimulate and I test through MATLAB, and the specific level is 1008 is the average reading difference that will determine either the harmonious mango contain any breakdown tissue or not. And the result get from the device is cross-checked with the original fruit. We will cut down and see and compare the result from both sides. Okay, this is the result that I get from simulating the data that I get using ANN, artificial neural network, and KNN, that is K nearest neighbor. So all of the data I get, I place in the MATLAB and I check the accuracy. Okay, so for the accuracy of artificial neural network is 99. Okay, for the expected outcome is that I, as the researcher and developer of the system, hope that the acoustic input response and the ultrasound wave response will be tested. So the system is expected to be able to distinguish the harmonious mango that contain IFR and the harmonious mango that doesn't contain any IFR. So the result shown on the device is expected to be accurate, as there are 2 sensors and 2 devices calculated and measured to ensure the accuracy is highest as possible. So that is all for my presentations. Thank you.